Hey guys, welcome back to my channel. Today, we're gonna go through the basics of um, trees and graphs. So, what is a tree? Tree is like a subset of graphs. So, graphs are any type of data structures where you can separate it into nodes and edges. Nodes are the like the ones that we went through in the linked list type of solutions. So there's a node, and then what's connecting the nodes are the edges. And usually it's used when you want to find the fastest solution to the root, from the root of the node to the end path. Uh, and this is usually done by traversing through the depth first search. Um, Yeah, first some terminologies. Um, so like I just said, there's a tree, and then the top of the tree is called a root, and then the side, and then for the binary tree, a type of a tree, the there's a parent node and a child node. Child node is where a parent node can be separated into two children nodes, and the maximum number of nodes that children can have is two. It cannot be more than that, but it can be less than that, so one or two. If it's less than two, that means there's no children. So it's left unattended. So that means it's just a leaf. In this case, we call it a leaf. Uh, what else? Nodes, edges, roots, parent, children, trees. Um, and yeah, graph. Um, in computer science, we talk about graph theory. It's all about um, trying to solve a problem using nodes and edges and finding the fastest solution. Mm, yeah, I think that's the basics of it. Maybe let's try to solve some question. Uh, Let me share my screen. Okay, maybe I can do it on my Visual Studio. And also, what's different uh, for the depth first search um, is that it chooses a branch and goes down as far as possible. And then once it fully explores its branch, it backtracks until it finds another unexplored branch. And it's usually done recursively. So we need to backtrack up the tree after reaching the end of the branch. So DFS is typically implemented using recursion, um, like I just said, but it can also be used. It can also be implemented using uh, a stack. So you just iteratively go through uh, the elements of the stack. So I'll just write a simple example of recursion, recursive DFS to visit every node in a tree. So let me just go here. Ah, this is bulk. So basically, each call to DFS is visiting the node. So we're gonna visit the left node, given that there's a root and there's a left node and right node, before visiting the right node, which is the child node of the root parent node. So that would be when we define DFS of a node, and if node is none, we return nothing, right? And then else we recursively call the left side of the node, which is DFS node.left. This is just a pseudocode, so we're just assuming that node already has a definition of a left and right. Same goes for DFS node.right. So we first go through the left, and if there's a node that's empty, we go to the right, and then we return the end result, which is DFS. Am I correct? Test node, if node, none, we return. We call again. Call. Yeah, so this is the basics of it. Oh no, we just return here. Yeah, so this is the basics of it. We just quickly went through the first search. Yeah, tomorrow we're gonna go through how to the different ways of traversing through the DFS, and there are some different ways. And apparently, depth first search is like one of the mostly used method in terms of solving algorithms, trees, and depth first search. So I think it's best to take some time in gauging this information. And tomorrow we're also going to solve some questions as well. So yeah, stay tuned. Thank you guys all for listening, and yeah, see you tomorrow.